Guys, for all the solutions of this book, visit forthesakeofeducation.com. I've been working hard of putting all the problems into one convenient place for you to be able to do your homework easily. So pay us a visit.
Alright guys, let's do this problem that says the rod supports a weight of 200 pounds and it's spin at the end A. If it also subjected to a couple moment of 100 pounds per foot, determine the angle theta for equilibrium. The spring has an unstretched length of 2 feet and a stiffness of K is equal to 50 pounds per foot. So let's get to it. So drawing the free body diagram, you know that you have a force here going up. I'm going to call it F of S. And I'm just going to draw this angle right here. This is also the angle theta, which is right here. Then we have the weight going straight down, which is equal to 200 pounds. And let me also draw this angle right here, which is also theta. And then you have a reaction at A going up. And you don't have a horizontal reaction because there's no other forces. And as you can see, there's absolutely no force pushing this assembly side to side. So there's no horizontal reaction. And I'm going to call this reaction AY. W and F of S. Okay, so and you know that W is equal to 200 pounds. So all they're really asking us is the angle theta for equilibrium. They're not really asking us for nothing else, so that's what I'm going to focus on. Assuming counterclockwise is positive, you know that the sum of the moments at A is equal to 0. And this is equal to, first you have the moment minus 100 pounds right here, 100 pounds per foot. Then you have 3 times 200, which is the weight, times the cosine of theta, which is 3, which is this distance, and 200, which is the weight, times the cosine of theta, because the weight has 2 components, this component and this component, but this component is not generating any moment because it's moving straight away from the assembly, so we only need this part. And this is also negative because it's also trying to turn the whole assembly clockwise. And the last part is the moment created by the spring, which also has a component that is parallel. A component that is perpendicular and a component that is parallel to the assembly, to the rod. The component that is parallel, which is this one, is not generating any moment, so we only need this one. And we know that the angle theta, so it is 6, which goes 6 feet, which is the whole length of the rod, times F of S cosine of theta. And it's positive because it's trying to turn the assembly counterclockwise. So here we have 2 variables. We have theta and we got F of S. But we can find F of S. We actually know F of S. F of S is equal to K times 6, which is the length of the rod, sine of theta. Right, K being the constant of the spring. Theta is right here, and as you can see, this triangle right here, I'm gonna redraw it right here. Looks like this. This is theta, and this distance is the distance that the spring was stretched. Because when the angle is 0, it says right here, it has an unstretched length of 2 feet, and you know that at 2 feet, the angle is 0. When the angle is 0, the spring is unstretched. So this distance right here is how much it was stretched times the constant that gives us the actual force. So it's basically giving us, because we have 50 right here, we have F of S in terms of the angle, which is 300 sine of theta. So we're going to replace that. And I'm going to move the 100 to the left. So this is going to look something like this. 100 minus 600 cosine of theta, which is this first term, a little simplified. And the second term should look like plus 1800 sine of theta cosine of theta. So if we divide this whole thing by 100 to make it a little more manageable numbers, we get 1 is equal to 18 sine of theta cosine of theta minus 6 cosine of theta. So we have an equation and we have only one variable, which is theta, and it's actually what we're looking for, the angle theta. So all we have to do is solve this equation now. This equation is a bit complicated to solve because it's not a method I use a lot in this book, but let's just walk through it. I'm just gonna walk you up to the steps that you should know, and if anything you can, it will help you guide you in the right direction. So I know that sine of theta is equal to 2 tangent of theta over 2 over 1 plus tangent square of theta over 2. This is a trigonometric identity. And I know another trigonometric identity, which is cosine of theta is equal to 1 minus tangent of square of theta over 2 all over 1 plus tangent square of theta over 2. And I'm going to replace sine of theta, cosine of theta, and cosine of theta for these two trigonometric identities. And it's going to look like this. 1 is equal to 18 2 tangent of theta over 2 all over 1 plus tangent square theta over 2 times 1 minus tangent square theta over 2 all over 1 plus tangent square theta over 2 minus, and I'm going to write it down here, I'm running out of space, 6 times 1 minus tangent square theta over 2 all over 1 plus tangent square theta over 2. And this is how this function is starting to get messy, but this is as messy as it gets. Now it's just gonna getting simpler and simpler and simpler until we solve it using Newton's approximation method. So let me go to another slide. The right slide, okay. So I'm basically gonna replace tangent of theta over 2 by x, okay, just to simplify this whole thing. And now our equation is gonna look like 1 is equal to 18 times 2x over 1 plus x squared times 1 minus x squared over 1 plus x squared minus 6 1 minus x squared all over 1 plus x squared. Now it's starting to look a little slowly prettier. Now basically I'm just gonna use some basic algebra to start simplifying this equation and get it looking like a standard polynomial is equal to 0, okay? So in our next step, this is gonna be like 1 is equal to 36x minus 36x cubed all over 1 plus x squared all squared minus 6 minus 6x squared over 1 plus x squared. So I'm gonna do the division now. They have a common denominator, plus x squared all squared, and this is 36x minus 36x cubed minus 6 plus 6x squared minus 6x squared minus 6x to the 4. These two cancel out, and in the next step I'm going to multiply this denominator by this 1 to move it to the other side of the equation, and it looks like this. 1 plus x squared all squared is equal to 36x minus 36x cubed minus 6 plus 6x to the 4. I have to solve this to look 1 plus 2x squared plus x to the 4 is equal to 36x minus 36x cubed minus 6 plus 6x to the 4. And now I'm going to solve for 0, and my polynomial is going to look like 5x to the 4 minus 36x cubed minus 2x squared plus 36x minus 7. Alright, so you have this polynomial, everything in terms of x, and you need to solve for x. You can do this manually. I'm not going to go through all the steps of doing this manually because it would be too time consuming, but if you wanted to do this manually, you could use Newton's method of approximation. One of my favorite methods, like matrices if you've been watching all my other videos. But we're going to plug this into our calculator, and we're going to get that x is equal to minus 1.0426, 0.20517, or 0.91946, or 7.1180. This is what x can be. Now remember, we said from before that x is equal to the tangent of theta over 2. Oh, look, I have it right here. So I'm going to make a nice little table right here. This is what the very last step. You have x and you have theta, right? So if x is equal to tangent of theta over 2, then theta is equal to 2 tangent inverse of x. Basically, you're just solving for theta. And we're going to write each of our solutions right here. Minus 1.0426, 0.20517, 0.91946, and 7.1180. Now, you're going to plug each of the x values into here, but you have to remember something. In your calculator, make sure you switch it to radian mode. Use radians. Different calculators have different ways of setting it. In the calculator I'm holding in my hand right now, which is TI 36X Pro. It's one of my favorite calculators for school. They don't really give you too much crap about this calculator, and you can solve these polynomials. But in this calculator, you basically have to click on mode, and then on the first row, select radians and press enter. So make sure that radian mode is selected in your calculator. Then write this function and x with each of these values. And the value that it returns, again, is on radians. So if you wanted to convert it to degrees, you have to multiply by 180 and divide it by pi. Let's put it here, solutions. You multiply, so you have to convert the solutions back to degrees so they make more sense as you analyze which ones are right and which ones are wrong. So when you do, you should get that. I'm going to write the values of each one. The first one should give you a negative 92.38 degrees. The second one should be 23.19 degrees. Third one should be 85.19 degrees. And last one should be 164.01 degrees. Now, just by looking at the diagram, you can tell that theta is somewhere in between 0 degrees and 90 degrees, right? So the only two answers are the second and the third. And like a previous problem, they usually tell you to find the smallest one. But in this case, both answers are right, because they're not asking you to the smallest one. So theta is equal to 85.2 degrees or 23.2 degrees. Final answer.